Hi everyone. Today we are talking about the tangent ratio, and we're talking about how to find trig angles when you're not, trig functions when you're not in the unit circle. So just a quick review here. All points on the unit circle are considered x, y. It's just that when we start talking about trig in the unit circle, they become in terms of cosine and sine. So there's nothing different really. X comma y, we just use notation of cosine theta comma sine theta, because remember, of course, that's this side adjacent and the side opposite. Sine is opposite, cosine is adjacent. Okay, so now when we start talking about tangent, because tangent is sine over cosine, we're looking for the y value over the x value. So the tangent at 30 degrees, well, up here above at 30 degrees, my point is square root of 3 over 2, comma, 1/2. So if I think about that in terms of a ratio of the y value over the x value, then I get 1/2 over the square root of 3 over 2. So that ends up as, if I keep change flip, 1/2 times 2 over the square root of 3. The 2's will cancel here, and I'm left with 1 over the square root of 3. I just have to rationalize that by multiplying the top and the bottom both by the square root of 3 over 3. I end up with, top and bottom by square root of 3 over 3, square root of 3 over square root of 3, and I end up with an answer of square root of 3 over 3. Now the tangent at 45. Well, that point at 45 degrees is root 2 over root 2, comma, root 2 over root 2. So, taking the square root of 2 over 2 over square root of 2 over 2, and that's one fraction over itself, and so that is equal to 1. Now the tangent of 60, well, the point at 60 degrees is 1/2, comma, root 3 over 2. So I'm going to take the y value, square root of 3 over 2, over 1/2, the x value, and get square root of 3 over 2. Remember, simplify that with keep, change, flip, and I will get, because those 2's will cancel, the square root of 3. Okay, next page, I'm on to page 12 here. I want to find the point on the unit circle that corresponds to this real number. All right, so 2 pi over 3. Well, the xy point that corresponds to 2 pi over 3, that's 2 sets of 60, that's 120, that is right there. That's a reflection from this point, the 60-degree reference angle from quadrant 1, and so that is the point negative 1/2, comma, square root of 3 over 2. Pi over 6, right here in quadrant 1, that's my 30-degree angle, that is square root of 3 over 2, comma, positive 1/2. And 7 pi over 4, that's down here in quadrant 3, and that is a 45, 90 reference angle, or triangle, 45-degree reference angle, and that is the square root of 2 over 2, comma, negative square root of 2 over 2. Okay, now I'm starting to evaluate trig functions all over the unit circle. I'm going to do a couple of these and skip around just to show some examples. So if I want the sine at 3 pi over 4, that's over here in quadrant 2, and that would be the square root of 2 over 2, because the y value of that coordinate on a 45-degree reference angle is square root of 2 over 2. It's in quadrant 2, so the y value is positive. Okay, let's look at the cosine at 5 pi over 3. That's 5 sets of pi over 3, that's 60. 5 sets of 60, so that's 300. And that is going to be right here. So that's a 30-degree reference angle. And I'm looking, a 60-degree reference angle. So I'm looking at a cosine of positive 1/2. Okay, let's look at the tangent over here on the right-hand side of negative 5 pi over 6. That's a negative rotation of 5 pi over 6. That gets me over here to pi over 6, which is a 60-degree reference angle in quadrant 1. The cosine at negative 5 pi over 6 is going to be, is going to be 1/2. the sine at negative 5 pi over 6 is going to be square root of 3 over 2, and then the tangent there is going to be the y value, square root of 3 over 2, over 1/2. But I've got to do that keep change flip, square root of 3 over 2 times 2 over 1, and that gives me a tangent of the square root of 3. Moving on to page 13 now, I'm going to talk about finding these 6 trig functions for just this one value, 3 pi over 4. Well, I find 3 pi over 4 in my unit circle by taking 3 rotations around, 3 rotations of pi over 4. So 1 pi over 4, 2 pi over 4, 3 pi over 4. That's a reference angle of 45 degrees, and so the sine is the square root of 2 over 2. The cosine is the square root of 2 over 2. The tangent is going to be 1. The cosecant is going to be the flip of that, so it's going to be the 2 over square root of 2, but I have to rationalize that. And so it's going to be just the square, come out just as the square root of 2. The secant is the flip of cosine, so it's the same thing. It's the square root of 2. I have to be careful though, because the cosine is, you may have caught this, is negative in quadrant 2, so I have to make sure that my secant is negative. I also went too fast. If tangent is y over x, I have to make sure that that x value, that negative x value changes tangent sign as well. And cotangent is the reciprocal of tangent, so it's going to be negative 1, because it's just going to be the fraction over itself in the opposite way. Okay, now these functions are all periodic functions, which means that they can just you can keep making more rotations around the circle. So the sine at 390 degrees would be 360, and 30 degrees past that is at pi over 6. We know that's a 30-degree reference angle, and so the sine at 390, even though it's not within that 360 range, it is 30 degrees past it, so the sine there is going to be 1/2. Similarly, if I took the cosine at 15 pi over 4, I'd be going 15 times around the circle at pi over 4. So I could count out 15, quarters. Or I could think about it this way. Wouldn't 12 quarters be 3 times around? 12 quarters would be right here at 3 times around the circle, like 2 pi over 3, then another set. Because in one full rotation of the circle, there are 8 pi over 4. So 8 pi over 4 would get me around once. Oh, sorry. Then 7 pi over 4 would get me around right there, 3/4 more time. So my reference angle, because it's a pi over 4, maybe you don't even have to travel all the way around the circle. You can just see that because it's a pi over 4, it's going to be a reference angle of 45 degrees. So it's going to be something to do with the square root of 2 over 2, and it's either positive or negative. In this case, it's in quadrant 4, so it's positive. Okay, that wraps up day 2. Moving on to a reminder now of these, the last 2 pages in these notes of the 6 trig functions. I've got them up here, sine, cosine, and tangent, but then their reciprocal trig functions are just what it says, the flip. So the cosecant is the flip of cosine, the secant is the flip of, the cosecant is the flip of sine, the secant is the flip of cosine, and the cotangent is a flip of tangent. So what you get your answer, you just, for sine, cosine, or tangent, you just flip it over. But the other way to think about it is like this. If the sine is with tangent, is if tangent is y over x, then cotangent is x over y. So you don't even have to necessarily get the answer and flip it over. You can just flip it over and then work through the answer. So in these problems, you're given the length of 2 sides, but you have to find the third. That's when the good old Pythagorean theorem comes in, that leg squared plus leg squared equals hypotenuse squared. So x squared plus 25 is going to be equal to 36. X squared is going to be equal to, 36 minus 25, I believe that's 11. So x is going to be equal to the square root of 11. Okay, so now here's theta, my reference angle. I've got the square root of 11 here for this leg. The sine of this is 5 over the hypotenuse, so it's going to be 5 over 6. The cosine is the square root of 11 over 6, and the tangent is 5 over 6 over square root of 11 over 6. So I've got to rationalize that. That would be 5 over 6 times 6 over root 11. The 6's will cancel. 5 over root 11. Rationalizing that, I get 5 square roots of 11 over 11 for the tangent. Cosecant is the flip of sine, so I flip that fraction over. Secant is the flip of cosine, the reciprocal of cosine, so I flip that over. Oops, 11. But I have to rationalize, so I get 6 square roots of 11 over 11. Cotangent is the flip of the reciprocal of tangent, and so it would be the x value over the y value, so it would be square root of 11 over 6 over the y value, which is, oh, sorry, I'm making this one more complicated. I made tangent way more complicated than it had to be as well. Let's make cotangent simple. Let's just make it, opposite over hypotenuse. I got it before, sorry. So let's do that again. The cotangent is the x value, which is the square root of 11 over 6, right? Opposite over hypotenuse, the sine over the cosine, which would be, square root of 11 over 6. I got a little confused. And then the, I'm realizing my mistake here. This should have said the sine of theta over the cosine of theta, not just y over x. That works in the unit circle, but here I have to take both the opposite and the hypotenuse. So back here, not thinking about it in terms of the cosine of theta and the sine of theta. The sine of theta here is 5 over 6. So I take the square root of 11 over 6 and I multiply it by 6 over 5, and I get the square root of 11 over 5. Okay. Same thing, same idea here. Sorry for the confusion. You have a couple that you can practice, and the same idea is going to apply to these other examples, which in the interest of time I am not going to show, but I'm happy to show in class if you want some more examples.